Hello everyone, today I'm going to present you a recently accepted paper titled Pedobarographic Statistical Parametric Mapping of Plantar Pressure Data in New and Confident Walking Infants. I want to start by saying that plantar pressure data can be defined as a two-dimensional continuum characterized by smoothness and distinct structural bounds. Plantar pressure data has been reported and analyzed mainly with regional masking analysis, which is the conventional approach adopted in adults, children, and infants. However, limitation of its use relates to the treatment of the two-dimensional pressure field as discrete. As a solution, pedobarographic statistical parametric mapping, also called PSPM, treats pressure in its meaningful two-dimensional field, but it's never been reported in infants' pressure data analysis. Therefore, the aim of this work was to detail the implementation of the PSPM data processing framework to compare plantar pressure in new and confident walking infants. Collected pressure data in 6 females and 6 males at the onset of walking and again when they were confidently walking. Our testing protocol involved walking in a nursery-style environment where infants were able to walk in any direction as opposed to being limited in straight-line walking, thereby resembling their everyday natural behavior. However, this led us to capture plantar pressure data highly variable in shape, oriented highly differently in the Euclidean space, and characterized by high intra- and inter-individual pressure variability. In our processing framework, we consider homologous pressure events by performing within-subject registration with an enhanced iterative closest point algorithm and between-subject registration with the coherent point drift algorithm. Statistical analysis was finally undertaken with a non-parametric SPM1D per t-test between walking stages and non-parametric SPM1D linear regression between pressure and body weight. As a result, comparison between stages of walking revealed the presence of a significant increase in pressure in the central left forefoot, and we tried to understand why this happened by considering first possible anatomical changes. However, our stages differ only by 2.2 months, so it is really unlikely that anatomical changes at this stage would occur in a way to influence foot function. Another explanation could have been the increase in body weight, but our analysis didn't demonstrate its influence on plantar pressure data. Nevertheless, it has been shown that increasing walking speed leads to increasing pressure in the forefoot in infancy. And such changes in our sample was possible as infants acquired more confidence in walking, thereby accomplishing quicker steps. And our results were never demonstrated before, and this can be due to differences between the methodology adopted in this work compared to the conventional masking approach. And considering regions of the foot separately limits the consideration as to where changes in pressure occur in the foot anatomical correspondence. For example, we could have differences in the central forefoot or different in the medial or lateral forefoot, or perhaps in both, but we don't get to know where exactly if we don't consider the meaningful spatial domain of the foot. So this supports that the methodological approach presented in this work is more suitable respect to the conventional masking approach and could therefore be used in future studies exploring plantar pressure data in infancy. Thank you for watching.